Okay, welcome to Davika Academy. Today we are looking at another episode about integration in integration, change in variables, and we are looking at bound and even powers of sine x and cos x. Remember, if you have not subscribed to this channel, I think it's the right time to subscribe, and again share with your friends and like some of the videos. Again, leave a comment down there for any question that you need us for clarification or you need to consult. For moving forward, we'll start with some of the questions. So here let's check the following practice questions. So we have this one, cosine of cubed dx. We want to get the integral of this. So in this case, if you look at this is odd power. 3 is odd power of cosine. So it means that if we really want to work out this one, we'll need to split this cos 3 cos cubed to cos square by cos x. So that now in this splitting here, we can introduce one of the main idea that we normally have, which is called the cosine identity in trigonometry. So here we have cosine squared being equal to 1 minus sine squared x, or the difference between 1 and the sine squared x. So if I substitute down in this point here, then you can see that we'll have the integral being to this by this one. Now at that junction now, it will mean that we'll now be able now to introduce a variable, the variable t, and we let now in this case our variable t to become sine x. So if you do dt dx, or you get a derivative of t in respect to x, then you'll find that this relationship is accurate. It is accurate. And then it will mean that if we now substitute t where we have sine x, then we'll have this kind of relationship here. 1 minus t, okay, square dt. Maybe to clarify what have happened there is that dx, this one, okay, you can see in dt is cos x dx here. That means what we have left with is only for the part of 1 minus sine squared, which is this one. So you can see that. And when you apply direct integration, then this will be 2. And what we need now to do next is just to substitute the x, the t now, with its respective substitute. And thereby we'll get this as our solution for that. So kindly note that the trick where it is looking at an identity from the trigonometry rule that can be fit your thought, and if so far you have not supported our channel, kindly support it by clicking or by subscribing to it for our both of our good. Okay, let's look at another example here. Now I'm looking at even power of cosine. If you look at this even power of cosine here, cos contra of 4, power 4. And now to recall and given now identity, which is here. So if you check these two, cosine squared of x is 1 plus cos 2x. So this to mean that if I really want to get cos 4, and you see here, this part here is cosine squared, I need square of this. So if I look clearly here, it's like I'm talking about cosine squared x being same as 1/2 all these, or 1 plus cosine 2ax. Okay, yes, like that. That means if I want to get cos power 4, I'll square this, and indeed also I'll square also this. So, and that's the reason now we are having this kind of scenario here. So there is a bracket here for the whole of that. So that if you have you expand this one, you'll see that you are going to get, this is first part is okay, it's 1/4, because it's half squared. That's no problem that. But if as I expand the other part here, you can see I'll have this kind of relationship here. Okay, so that I'll be able now. So we have integrating and opening. We'll have this. So that now you substitute the solution here. You'll find substituting x, main x. You have this one is the true solution for this. If you have a question on either step that you see I've omitted here because I believe it's trivial, you can just leave it a comment there and be able to clarify. But if you follow the procedure clearly, you find that this is now what you are training. Remember, the tip is now to relate the question at hand with a given trigonometry rule that exists, and then you see the flow coming out. Okay, and lastly, okay, I want to check on this one, whereby is another function of owned power. Okay, so if you look at this one here, I'm having integral of cosine 4 theta of sine theta and theta. So what I need to do here is to come up with this, remember this, sine alpha, sine beta is same as this. So that from here now, I'll be able to come up with the values of beta and alpha. Once I get the sign of beta and alpha in response from the equation here, then I'll have written this equation now here into this form. And once I've done this to this form, then it will mean I'll be able now to apply simple integration to both of these, and then I'll be able to come up with the answer. So working on this and this one together, you'll see that in this case here, our sine in this case, so that we come up with a relationship which is true. You find if you compare this relationship here, you'll see that what we have here is so that it looks like ours. We'll need to have now yes, sine alpha different of sine, because for relationship to come, it must be something comparable. So this will be same as now the two it is now out. It's now up on the other side. Cos of alpha plus beta over 2 sine, okay, sine alpha minus beta over 2. Okay, so if you look at this now, clearly you can see now, if you leave there, you'll find that we have from our question now we have cos 4 theta. So I'm talking about alpha plus beta over 2 is like 4 theta, which tells me that this alpha plus beta is same as actually 8 theta. Same at 8 theta, because you have 4 theta. That's first equation. Second equation will be now alpha minus beta will be same as we have sine theta, so this will be 2 theta. 2 theta. So these are two simultaneous equations, and we know how to solve simultaneous equations. And if you have a question that I have done a tutorial on this, on how to solve simultaneous equations, so you can refer there. Okay, so you can see from here I have 2 alpha being same as 10 theta. I mean theta. So it will mean that our alpha is same as 5 theta. That's our alpha. That's our alpha. Then it will mean that then our beta will be same as you substitute clear there 3 theta. 3 theta. So and therefore now our equation now can be written as an integral of a half, yeah, sine. We now know alpha is what? We know alpha is 5 theta. Okay, minus sine beta. We know beta is 3 theta. 3 theta. So all this is in a relative to with respect relative to theta. So if you look clearly, this is just direct substitution, and if you integrate